Okay, so now we're going to talk about section 5.2, which is on multiplying polynomials. So again, hopefully this is a review and you've seen it before. First, we're just going to multiply monomials into polynomials, and then we'll get into different larger polynomials or second, third degrees being multiplied together. Give me just 1 second. Just get this into the right section of. There we go. Okay, so let's switch over back to the document camera. Switch back to the document camera. Boom. Multiplying polynomials. So multiply polynomials is different than adding and subtracting. You do not have to worry about like terms. That's not how you don't have to worry about multiplying with like terms. Whenever we went over section 1.6 and 1.7 in the previous sections, and they went over how when you multiply variables, you just add the exponents. We'll have to use that knowledge that we've already gained. But it's very straightforward. So let's look at first at multiplying monomials into polynomials. So let's say we had something basic like 3x squared times 2x minus 5x squared y to the fourth. Okay, something like this. So we've got this nice monomial right here, single polynomial, and then we've got the binomial. Okay. And if we're going to multiply these, and really I'm going to teach this with examples, it's just the easiest way to do it. But if we multiply these, we're really multiplying just single terms or two terms together twice, right? We're going to distribute, right, because it's parentheses. We can't add these together. They're not like terms, right? Always remember order of operations. I know I'm kind of all over the place right now, but remember order of operations. Order of operations states, hey, if we've got something in a parentheses, you need to do it first. Well, we've got 2x and we've got 5x squared y to the fourth. These are definitely not like terms. So we cannot subtract these together. So if we can't subtract them together, then go to the next operation. Well, we need to multiply. So we can multiply this through this 3x squared to both of these terms. Now, remember when you multiply these, this is old stuff, but 3x squared times 2x, you multiply the coefficients, 3 times 2, that's 6. X squared times x, that becomes x cubed, right? And then when I multiply the second one, 3 times negative 5, that's negative 15. And then x squared times x squared, that's x to the fourth. Now the y to the fourth has nothing to multiply by, so you just leave it there, okay? You leave it there, no big deal, okay? So let's look at something that's a little more common that we're going to see throughout this class and the next class. Let's say we had something like negative 2x to the fourth times 3x squared minus 5x plus 10. Something like this, okay? Negative 2x to the fourth times 3x squared minus 5x plus 10. So if I'm going to multiply this one, again, I can't add anything inside this parentheses, right? I've got an x squared, an x, and a constant. So therefore, these are not like terms. So I'm going to multiply the monomial out here to each one of them. I do like drawing the little lines in. It just reminds me to do that. Look, the most common mistake, of course, is going to be multiplying just the first terms together and not distributing this monomial all the way through. So negative 2x to the fourth times 3x squared, that's going to be negative 6x to the sixth, right? X to the fourth times x squared is just x to the sixth. Negative 2x to the fourth times negative 5x squared, that's going to be positive 10 x to the fifth. And then lastly, the constant, well, there's no x to multiply by, but you do have to multiply the 10 and the negative 2 together. So you get negative 20 x to the fourth, okay? And then just a little reminder here, and then kind of something that's neat in a way. Notice when we multiply these together, the degree of this trinomial is 6, right? Before we multiply them together, the degree of the monomial out here was 4, and the degree of the trinomial was 2. Hey, you add those together, you get 6, right? So when you multiply polynomials together, if you wanted to know, which we don't need to know this now, later on we will. But when you multiply them together, if you want the overall polynomial's degree in the end, you can just add up each polynomial's degree that's being multiplied, okay? This polynomial's degree was 2. This polynomial's degree was 4. 4 plus 2 winds up being 6. So the quotient polynomial, I guess, or not quotient, but product polynomial, after you multiply, is just 6. Okay. Now, you don't have to implant that one in your brain yet, but it is kind of neat information, okay? So let's look at another example of this one, okay? Let's say sun's starting to come out. Yay! I'm gonna steal this one from your book, actually. Sneak over into the homework just to see how your book is asking some of these questions. Ooh, yeah. Oh, that's got a Z in it. Okay, let's look at number 10. I didn't choose a weird one like this. Negative 6b squared z times z squared a plus baz minus 3b. Okay? And again, we've got a polynomial out here, a monomial. We've got a trinomial in between. We can't add anything in this trinomial, right? Z squared a and az can't add together because the z is not squared, right? If it was, you could add those together because they'd be common terms. The 3b, of course, the other two don't have a b. So we can't add what's inside the parentheses, so we're going to multiply this thing through. Okay, we're going to multiply this thing through. Negative 6. Now, really, if there's not a number in front, remember there's a 1 here. We just don't write it. So this winds up being negative 6. I'm going to write these alphabetically. It's bothering me that they're not alphabetically. So if we notice here, we've got a b squared z and a z squared a. Well, there's a single a, so I'm going to write that first. Okay. There's no b's except this b squared. So the only thing really to combine is the z and the z squared. So that becomes z cubed. Okay. That becomes z cubed. So the first term, when you multiply this monomial into the first term in this trinomial, becomes negative 6 ab squared z cubed. Okay, so let's do the second one. We get negative 6, because again, it's a 1 here, right? We've got a single a there, so I'm going to write that down. We've got a b squared and a b, so b squared and b, so it becomes b cubed. And then we've got a z and a z squared, right? Actually, I think that's our degreed term, right? Nope, these have the same degree. 1, yeah, these have 6. This is a degree of 6. This is a degree of 6, right? So yeah, they have the same degree. Okay, so then now let's multiply the last terms together. Not the last terms, but the monomial and the last term. So negative 6 times negative 3, that gives me a positive 18. I don't have a b here. I'm sorry, I don't have an a here, right? So I'm going to go to the b's. B squared times b, that's b cubed. And then we've got a z. We don't have a z over here, so we're going to not forget that z. Okay. Oh, man. It's a little more intricate than our examples from before, right? Kind of neat, though. Okay. Kind of neat. Questions about that before we get into just multiplying? I didn't give you homework in that last section, did I? Oops. I'll give it to you in this video. Remind me at the end, I'll give you homework from 5.1. Let's keep going. So now what if we need to multiply, two polynomials that are not, one of them is not a monomial. So if we needed to do that, we're going to have to make sure to really keep distributing. You can call this the FOIL method if you want, but in the end, you're just distributing, okay? Let's look at an example. If we looked at, I'm going to steal this one straight from the book. Like x plus 3 times 2x plus 5, okay? So now we don't have a single term, right, being multiplied into a larger term or a larger polynomial, right? If we wind up here, now if you know FOIL already, you're more than welcome to FOIL, but I need you to understand really all you're doing is distributing, okay? You're taking this first term, you're multiplying it into both, And then you're taking the second term in this first polynomial, and you're multiplying it into both of them, okay? It's just distributing. So if we look at this, x times 2x, that's 2x squared. X times 5, that's 5x, right? 3 times 2, that's 6x. And 3 times 5, that's 15, okay? That's the FOIL. Your book goes over the FOIL method. I'm not going to call it that, but really you just have to distribute each term fully into the other polynomial, okay? You have to distribute each term fully into the second polynomial. So I'm going to combine like terms now, right? 5x and 6x. And this gives me 2x squared plus 11x plus 15. Okay, notice single degree polynomial, second degree polynomial turns into a second degree polynomial. Okay, kind of neat. Okay. Questions? Give you a minute to think about these. I'm going to give you like kind of a, I want you to try it on your own kind of quiz here in a second with these. But let's go over, well, what if it's not a single or a binomial into a binomial? What if it's like a binomial into a trinomial? So let's say we had 3x minus 4, and I wanted to multiply that into x squared minus 10x plus 2. Okay? So what if now we've got a binomial being multiplied into a trinomial? Okay? And what do we need to do? Well, I'm going to do the same exact thing I did on that last example. Okay? I'm going to multiply each one of these terms thoroughly into the other polynomial. So I'm going to take the 3, visually, this is what I'm doing. Taking the 3x, and I'm going to multiply it into all 3 terms. And then we'll get the blue out. I'm going to take the negative 4, and I'm going to multiply it into all 3 terms. Okay? And it's going to give me 6 terms, but what will probably happen is we have like terms and we can combine them. Okay? So let's start with the 3x. 3x times x squared, it's going to be 3x cubed, right? 3x times negative 10, that's going to be negative 30x squared. And then 3x times 2, that's going to be a 6x. Okay? And then negative 4. Well, negative 4 times x squared, that's minus 4x squared. Negative 4 times a negative 10x, that's a positive 40x. Negative 4 times 2, that's a minus 8. Okay? Let me know if I make a mistake. It's really easy to make a mistake if you're kind of flowing along here because there's so many terms. Okay, so let's combine like terms. I can see that I've got a negative 30x squared and a negative 4x squared. And then I see that I've got a 6x and a 40x. So we've got 3x cubed minus 34x squared plus 46x. And then the minus 8's by itself out there. Okay, cool. Boom. There we go. There, look, it's a 3rd degree polynomial. We had a 1st degree polynomial multiplied into a 2nd degree polynomial. It's going to give you a 3rd degree polynomial. Okay. Questions? Your book goes over a few ways to solve, to multiply these, not solve, but I want to get us familiar with this first. So I'm going to give you a little quiz. Actually, we'll do it down here. I'm going to give you a little quiz on multiplying these things through right now so we can really kind of grasp what's going on. And I'm going to steal them from your homework. So let's look at number So this is number 24. So try this one. 24, we've got 2n minus 9m times n minus 7m. So try that one. And then let's do a larger one here. Let's do let's do 50, or I saw one. Where did it go? 56. 56 says 3y cubed minus 1 times 3y cubed minus 6y plus 1. So try those two. I'm going to give you just a minute. I got to get some water. I'll be right back. Okay, try those two while I'm trying to get some water. Okay, keep working if you're working. I'm actually going to start on the second one because you probably should be the second one by now. So let's do this one. I'm going to multiply each one of these terms through. So the 3y cubed is going to go to all three parts. So I get, okay, I'm going to get 9 y to the 6th minus 18 y, now y cubed and y, so it's going to be y to the 4th, and then plus 1. So it's just the same thing. It doesn't change, right? And now I've got to multiply the -1 through, which is kind of nice because -1 just changes the signs on all of them. So minus 3y cubed plus 6y minus 1, right? Now I've got to combine like terms. It looks like there's only 2 like terms here, and they cancel each other out, which is kind of neat. So therefore, we wind up with 9y to the 6th minus 18y to the 4th plus 6y minus 1. Boom. Okay. And then now let's look at the first one. And again, I'm going to do the same thing. So I'm going to multiply the 2n times the n, so that's 2n squared, minus 14, let's write this in alphabetical order, so lmn, mn. And then negative 9 in n, so that's negative 9 mn. And then, well, I got just a little bit of room here, plus 9 times 7, which is what, 63? M squared. I ran out of room. So I can add the middle two together, though, right? Negative 14 minus 9. So that's 2n squared minus 3? That doesn't seem right. Right, yeah. 23 mn plus 63 m squared, okay? That was number 24 in your homework. Okay? Questions, comments, concerns? Okay. And again, you can go back and pause this and look at it, right? So let's look at now some kind of ones that look different. And I'm going to tell you this next one is my pet peeve is not the right word. What I've noticed, it's the one that confuses students the most, and they make that consistently the same goofy mistake. Okay, the same goofy mistake. It's understandable, and I'm sure I've ranted about pattern recognition in this class, but because of that, it creates a goofy mistake that happens all the time. And it looks like this. Let's say I gave you x minus 5 squared. Okay. Now look, we came, especially this class, we learned about distributing in section 1.6 and 1.7. And I know I talked about this there. So if you want to go back and look at that, you're more than welcome to. But our brains want to distribute that 2 to both terms, but we cannot. Okay. You cannot distribute that 2 to the x and the 2 to the 5 as an exponent because of that minus sign. Okay. That minus sign messes us up. We have to write this out as x minus 5 times x minus 5. And we have to distribute it through. So x times x gives us an x squared. X times negative 5, that's minus 5x, minus 5x, and then plus 25. Okay. If you distributed the 2 through, you're going to miss on the, you're going to forget, you're not going to even have the middle term here. It creates a trinomial, minus 10x plus 25. And actually, this trinomial has a special name. This is called a perfect square trinomial. And the reason it's called a perfect square trinomial is because it comes from a perfect square binomial, okay? In the next few sections, we're going to go backwards. We're going to go from this to that, okay? And we're going to talk about this perfect square trinomial again. But perfect square trinomials come from perfectly squared binomials. That's why they're called that, okay? And we'll talk about that in a few sections coming up, but don't worry too much about it now. Don't worry about the terminology. What I need you to know is when you've got a binomial being squared, that you actually multiply it out. Okay, you don't say it's x squared plus 25. Okay, very, 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 very extremely common mistake. Okay, Let's look at another kind of special multiplication. If we have like 2x plus 5 and 2x minus 5. Okay, these terms, these binomials, are called conjugates. And I don't believe your book will define that. I need to look this up. Okay. No, it's on page 355 though, and it's called the product of the sum and difference of two terms. But these have a much shorter name. It's called conjugates. Okay, and what's neat when you multiply conjugates, the middle term will go away. So if the first term is the same, 2x and 2x, and the second term is just opposite signs, what we're going to see is it's going to create two opposite numbers on the inside. Okay, so let's do that. Let's follow this out. 2x times 2x, that's 4x squared. 2x times negative 5, that's minus 10x. And 5 times 2x, that's a plus 10x. And then 5 times negative 5, that's negative 25. Okay? But notice it created opposite signs on the inside. So they cancel each other out. Negative 10x plus 10x goes away. So that leaves us with 4x squared minus 25. Okay? 4x squared minus 25. And again, this is called a difference of squares. Notice this first term is something squared, 2x. The second term is something squared, 5. We're going to talk more about that in a few sections, and we're actually going to go backwards, okay? We're going to go from here to here in a few sections. Don't worry about that. But this is just multiplying conjugates. And what's neat is, I mean, you do it the same way. It's not some new trick thing. You do it the same way, but what'll happen is the middle two terms will always cancel when you multiply by conjugates. Neat stuff. Okay? Neato stuff. Okay, and then you can multiply vertically. I really don't like the way your book does this. I think it's honestly just kind of confusing. I'm going to show you how I would do it if I multiplied it vertically. Okay? It is a me thing. So I'm going to do their example. It's example 8 on page 353 if you want to look this up. But they've got 4x squared plus 7 times x squared plus 2x plus 8. So if you are like, man, I don't like distributing each one of these through. I like things written in vertical format and multiplying. I don't know why you would want, but I'm just going to cover it because the book covers it. You don't have to do this. You can do what we've been doing all along. But if you wrote this out, let's say x squared plus 2x plus 8. Now we don't have to worry about writing the second polynomial with missing terms because we're multiplying. Remember when we added or subtracted, you did need the missing terms. But we're going to multiply, so times 4x squared plus 7. Okay. The way I would do this is I would first, I guess I'll kind of do what the book does. First multiply the constant to each term. So 7 times x squared would give me, I'm going to run out of room. 7 times x squared, kind of right over here, is 7x squared. 7 times 2x is 14x. And 7 times 8 is 56. Okay? And then you go to the 4x squared. You do the same things, but now we are going to line up with common terms. So 4x squared times x squared, well, that's going to be 4x to the fourth. I don't have one of those, so I got to kind of think of gaps here. So 4x to the fourth would be out here. 4x times 2x, that's going to be 8x cubed. And then 4x times 8, that's going to be 32x squared. So I can line those up. I know I'm running out of room. I really don't like this method. You can kind of toss it if you want. But now we just add vertically. So you wind up with 4x to the fourth plus 8x cubed. And then you add these vertically, 7x squared plus 32x squared, you get 39x squared. And then look, there's nothing over here. So plus 14x plus 56. Let's just not worry about that. Let's just stick to distributing because you know what? Why make something more confusing? And why do something two ways whenever one way works? Okay. I feel like Kevin on The Office. Why do more when less words work? Okay. But anyway, so let's not worry about vertical multiplying. If you want to learn about it, it's in your book. You're more than welcome to do it on the test if it works best for you. But I'm going to stick to just the regular type of distributive. Okay, we did square, binomial, we did subtraction. Now, your book goes into kind of other multiplying. I'm not going to give you the homework for all of this section because it goes into some goofier stuff. So don't worry too much about it. But let's go back first to 5.1 because I forgot to give you homework for 5.1. 5.1, the homework starts on page 346. And I want you to do 1 through, now I'll tell you a lot of these are real easy. And it'll just take you a few seconds on some of them, like what's the degree of this term? 7, done. 1 through 69 odd. And then in 5.2 for homework, starts on page 358. You can, let's do 1 through, I'm going to get real kind of picky. No, we'll do the vertical stuff. So 1 through 13. And then 21 through 37. And then 49 through 67. Now, all those are odd as well. Okay. So here's the homework. And I know you're like, oh, my Lord, Mr. Shirley, that's a ton of homework. I don't think I can get it all done in one night. And I understand. You're probably right. I mean, if you've got to work or if you've got kids and stuff, this would be hard to get done in one night. What I would suggest is that you do every other odd then. If you know that you can't get this done in one night, do every other odd and try to at least get to all the sections before we go on to the class tomorrow, which really with tomorrow's class, we're going to start on factoring, right? Yeah, we're going to start on factoring. So it's a different topic. Now we're going to go backwards, right? From multiplying to factoring. So we're going to go given a term, we're going to go backwards and factor it. Okay, we're not going to do this larger polynomials though. Okay, so any questions? Let me